The whispers in the morning.
This is the Easy World of Science, Her Majesty Easy World Science Channel. Nice to know that you're there. Today I'm going to handle hardness of water, hard water, and I'll not only be doing the talking aspect, I will demonstrate for you to understand what is actually hard water. So today I will combine tutorials with live experiments. So what I have today are those things that are needed to show you when water is hard and when water is soft, and how water can acquire hardness. First, what is a hard water? A hard water is a water that cannot easily form latter with soap, that cannot easily foam well with soap. It doesn't foam well with soap, which means it leads to wastage of soap during laundering. So what causes hardness of water? The presence of calcium or magnesium ion. The soluble forms of these two ions, the soluble forms of the compounds of these two elements, calcium and magnesium, gives water its hardness in nature, meaning, and the common soluble form of these two ions, calcium and magnesium ion, is in form of chlorides or sulfate. So calcium chloride can cause hardness of water, and magnesium chloride can also cause hardness of water, and magnesium sulfate can also cause water hardness.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Her Majesty Easy World Science.
And you know the best part?
It
makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Her Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is, when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously there's love in sharing.
Thank you! We'll see you there.
Then, calcium ion and magnesium ion are the two known cations, and they are divalent in nature that causes hardness of water. In titration, you can use compluxometric titration to determine the hardness of water using Erichrome black tea as the indicator. You stay subscribed for you to see where I've carried out this type of titration to know the intensity of hardness of water. Or you can use soap, a soap solution, or any detergent to check the titration, to check the level at which a particular water produces permanent foam or latter, and at the level where another water produces water. Then, naturally, water acquires hardness when it dissolves any of these ions. Most of these compounds in nature, the compounds of magnesium and calcium, they don't dissolve. Like calcium carbonate is insoluble in water, but if there is presence of carbon 4 oxide, water may dissolve the limestone in it, and that will give it hardness. So when we come to two types of hardness, we have temporary hard water and permanent hardness of water. That's temporary hardness and permanent hardness. So the one that causes permanent hardness is the same thing, the same ion, magnesium ion or calcium ion, or popularly calcium ion. But the difference is that the compounds that cause the two are not the same. So a temporary hard water is a water that can be softened by heating or by boiling. If you boil temporary hard water, you soften it by precipitating the soluble calcium ion to insoluble form. That is what we call temporal hardness of water, and it is mainly caused by calcium hydrogen triazocarbonate 4. That is the compound that causes that, because calcium hydrogen triazocarbonate 4 is a soluble salt of calcium, which when you subject it to heating, it will decompose into calcium carbonate, which is insoluble. So in softening hard water, your aim is to convert the soluble calcium ion into insoluble form of it. So the soluble compounds of calcium and magnesium dissolved in water is converted to insoluble form. And anything that will precipitate it into insoluble form is called a water softener. A water softener is any compound or any species, zeolite or perlmuttite, commonly sodium salts, that precipitates calcium ion from its solution, and it will also precipitate magnesium ion. So if you remove that calcium ion, which is interfering with the soap action, you have actually softened the water. So what I say about water softeners, I say water softeners are actually sodium compounds that are used to precipitate soluble calcium ions and magnesium ions from water. And over here, the water softener I have here sodium triazocarbonate 4. So sodium hydroxide is also a water softener. Sodium zeolite is also a water softener, or permutute, they are all water softener. Then STPP, sodium tripolyphosphate, is also a water softener commonly used in most of these soaps and detergents we have. Then we will see now what we mean by hardness of water. Over here, this is water, this is also water. And here I have, this is a detergent, which does not, which is not stopped by hard water. Hard water do not stop the foaming ability of soapless detergent. And the active ingredients here is actually this, the linear alkyl benzene sulfonoate. This is actually my product. I produce this particular detergent myself. So the active ingredient here is the linear alkyl benzene sulfonoate. Then, what I told you that hard water is water that cannot easily be lattered with soap, not easily be lattered with soapless detergents such as linear alkyl benzene sulfonoate, which means I have my soap here, this bar of soap, to demonstrate hard water and soft water. So the water I have here is deionized, and meaning it has been using ion exchange resin. This water contains no more interfering ion, so it's rendered as actually soft water. So this is the same water and this is the soap. So I want to check if it can easily be lattered with this soap. Camera right there. If you are seeing it, see it is already forming. It is already forming, showing that this is a soft water, very very soft. It is easily lattered with soap. See, it has formed latter, that is your foam. So this is a soft water, deionized. Then let me give it okay, this is the same water I collected from. I rinse this. So this deionized water now, I want to make it acquire hardness. So here is my calcium chloride. I want to introduce calcium ion into this water, and when I do that, it means it's now a hard water, and this is permanently hard water. Boiling cannot remove it because heating the chloride will not make it decompose to anything. So let me check the foaming ability with soap. Okay, so we put our soap in. See, instead of forming foam, you can see particles inside the water is no longer lattered. So before this particular water will be lattered with this soap, I have to waste a lot of this soap before. See, it's no more foaming. So rather it's forming sticky substances. Watch my hand. I hope camera is close. So this is a sticky, and this is what we call scum. So this is now a hard water. It is no longer, it's not easily lattered with soap. So, but when I continue, it might be lattered because I introduce more of the calcium ion. So at a long run, which means hard water leads to wastage of soap. See, it's not bringing any washing action. So it might interest you to know the chemistry of soap. This soap is actually sodium citrate or potassium citrate, or sometimes they call it sodium octadecanoate. This is soap. But in the presence of calcium ion, as you can see here, the calcium ion now reacts with this soap to form calcium citrate, that is calcium octadecanoate, and calcium octadecanoate is scum. So in the presence of hard water, soap forms scum. So if you have been bathing sometimes, you see there will be a kind of sticky substances around the bucket you are using. It shows that that water is a hard water. If you notice such thing that is sticky, like a thick something, you see it, that's it now. Then you have seen that this particular water is a hard water. It's not easily lattered with what? Soap. Remember, this is the same water I collected from. I did not introduce any of the calcium ion, the ionized water. So if I place back this soap here, it will still, see, it's lattered. It's foaming already. So we compare the two. So you see the difference between hard water. See, this is soft water, and over here is hard water. So there is no lattering here, but here is easily lattered with soap. So if I want to soften this water so that it can be lattered with soap, what I have to do is to treat it. This is permanent hardness. So permanent hardness is only removed by treating with chemicals and not by boiling. So permanent hard water is a water that can be removed. It is a water that is hard, that the hardness can be softened by reacting it with chemicals, not by heating. If I boil this, it will still be hard. Why? Because what I introduced is actually calcium ion in form of calcium chloride. And calcium chloride, heating it, will not change it to any form. It will still remain inside this water. So my job is to precipitate out the insoluble form, the soluble form of the calcium ion into insoluble form using sodium triisocarbonate 4. So sodium carbonate is a water softener, as I said earlier, and sodium tripolyphosphate, of which I used in this detergent, is also a water softener. Even sodium hydroxide will soften any hard water, permanently hard water. Okay, this is still the ionized water. See, the scum is very clear, even at the base, very sticky. So you might have been observing this. This is a common test to know if the water you are using is hard. When you bathe with water and soap and they are seeing sticky substance at the walls of the bucket you are using and on your hands, it shows that the water is a bit hard. And you need to use this process now. You add more. So now I'm going to add the same soft water. So there is still traces of the ion there. So in that case, I introduce my calcium ion, making the water now hard. So this calcium ion present has given this water this hardness, which means I'm going to find it difficult for it to form a substance like this with soap. So what I do, as you can see, to still give us back what you have seen before, see the scum is forming. So when I now treat it with sodium carbonate or sodium hydroxide, it will precipitate that calcium ion out. You can see white precipitate. See, it's now turning milky. This is the calcium. The milky color is nothing but calcium triisocarbonate 4. So when I filter it now, the remaining water is now soft water and it will be lattered with soap easily. So what I'm doing now is to soften the water. I'm reacting sodium carbonate with calcium chloride. What do you think will form? It will form calcium carbonate with the formation of sodium chloride. So this water is now softened. For me to get the pure water, I have to filter this or allow it to settle. On settling, I'll just tap off the surface. The surface aspect is now probably a soft water. So that is it for, let's just wait for this to settle. Okay, the filtration process is almost complete. What I did now, this is assumed to be the soft water now. Remaining behind here is the powdered calcium carbonate, as you can see. So I've precipitated the calcium chloride I've added here in form of calcium carbonate. So let me check if this can now be lattered with soap. So this is our soft water. So let's check if it will still form scum. Okay, you see, it's no more forming scum. It can now be lattered. So I've succeeded in softening this hard water initially. Remember, it was unable to foam, but now, after I've softened it with sodium triazocarbonate 4, you can now see it's forming latter easily now with soap. And remember that if you are at home doing this, it doesn't mean that if you don't filter this that it will not do well. The filtration is just to get the clean thing, because the calcium carbonate formed will not interfere with the washing action of the soap because it's no more soluble. It is insoluble. Whenever it is in insoluble form, it doesn't interfere. It is whenever it is in insoluble form, it doesn't interfere with the washing action. It's when it is still in soluble form. So what I mean is that even if you don't have the appropriate filtration means and the particular water is hard, you can treat it with sodium carbonate. It's affordable. You can buy it in most of the chemical shops, those shops that sell industrial chemicals. Yeah. So when you add it in your water, you turn it well. The precipitate forming, don't mind, you can continue with your washing because the precipitate is already insoluble and it doesn't interfere with the foaming action of the soap. Okay, that's it. Now, let me demonstrate for you the advantage of linear alkyl benzene sulfonoate based detergents, that is soapless detergent over soap. The advantage.
The whispers in the morning.
I love you. Thank you for watching.